Precision casting or lost wax casting holds a perfect balance between artistry and precision engineering. It's given the name precision casting due to its ability in creating parts with utmost precision, and its ability to achieve tight tolerances up to plus 0.005. Its unique process separates it from any other die casting process. The wax patterns are created to prepare an initial ceramic mold, based on your parts with extremely complex or simple designs. Lost wax casting process. Your parts for which achieving tight tolerances is a basic need are cast through lost wax casting. By replicating them from another model which is an exact image of your parts, it creates parts with thin walls that, if not extremely intricately designed, don't require any surface finishing. The lost wax process is based on many steps, including lost wax casting process. Casting step 1 to 5. Model making. A 3D CAD model of the parts is prepared accurately replicating the part size, dimensions, and other measurements. This step is of extreme importance to create an aluminum die. Creating a mold. A mold is created based on the 3D CAD model. The primary material for this mold is aluminum, which is used to create wax patterns later on. Wax pattern creation. Manufacturers create wax patterns that precisely replicate the original CAD design from aluminum die. Using casting wax, they pour wax in its semi-solid form into the die and adjust it to ensure complete coverage. Repeating this process is necessary based on production scale. For producing multiple parts, these wax patterns are connected using a runner. Shell building. After combining the wax patterns in a group, the shell building process begins. In shell building, the wax mold casting is poured into a ceramic slurry. The ceramic slurry coats the patterns, which work as a hard exterior shell. A small portion of this wax tree is left and coated to later remove the wax. Casting step 6 to 10. Dewaxing. After coating the wax tree, the dewaxing process begins. It's a process of removing the casting wax completely from the ceramic shell by baking it. That's the point where the ceramic shell is ready to produce your parts. And that's from where this die casting process gets its lost wax name. Burnout. It's important to make sure that no residual wax or moisture remains in the ceramic shell. To be sure, the wax mold casting undergoes the burnout process to remove any foreign materials from the inside. It undergoes approximately 1035 degrees Celsius temperature, which along with removing any materials, also solidifies and hardens it. Casting. The burnout process prepares the ceramic mold for casting and molten metal is poured. To initiate the casting of your parts, the metal is poured in a way that flows within the ceramic tree with the help of gravity and pressure. The molten metal was precisely distributed to each part of the ceramic mold. Cooling and shell removal. When the metal solidifies in the ceramic mold, it's time to remove the ceramic shell. There are 3 primary ways to remove the ceramic shell from the parts, either simply using a hammer, blasting, or high-pressure water. Sometimes, chemicals are also used to remove the ceramic shell. In the end, after removing the ceramic shell, the runner is also removed by cutting it, and the parts are individually separated. Surface finishing. However, the parts from lost wax casting don't require any surface finishing as they are already perfect, but sometimes incredibly intricate and complex parts require additional surface finishing. Parts undergo the sandblasting process to remove any additional residual ceramic and scales from them. Variations in the lost wax casting process. The lost wax process can have many variations, but the one process we discussed here is considered exclusive. For example, after burnout and before casting, sometimes there is an additional step where mold is preheated for the lost castings. What variation is best for your parts depends on its design and material. Lost wax casting metals. Lost wax casting's compatibility with a wide range of metals distinguishes it. It works with aluminum, steel, bronze, stainless steel, iron, brass, bronze, and etc. Aluminum and its alloys are ideal metals for lost castings. The incredible machinability and corrosion resistance of aluminum makes it a high-level choice for the majority of parts. Moreover, the fluidity of aluminum allows for the casting of parts with thin layers. When alloyed with other materials, aluminum's strength and physical properties can be further developed. Advantages of lost wax casting. In this technologically advanced era of manufacturing, the lost wax casting is still standing strong as it sets near zero limitations on your parts' dimensions, size, and design. Lost wax casting. It offers incredible flexibility and freedom as compared to other casting processes. The unique casting process, design flexibility, and material compatibility of lost wax casting make it stand out from the rest of the competition and enable it to offer the following renowned benefits. Material compatibility. It can cast parts for nearly every industry in your every application without any design or material limitations. From aluminum to nickel and every other metal is incredibly compatible with lost wax casting. Smooth finishes. In the majority of cases, your parts don't require any additional surface finishes, because the natural finish your parts get from lost wax casting is excellent. Size range. It can handle parts with every size, dimension, and complexity in design with ease and can cast them to perfection. Production turnaround. In this high-paced industrial time, where high-volume production is accepted in a short time, lost wax casting has proven itself. It's an extremely fast and repeatable die casting process, and the parts it produces are ready to be shipped right after casting. Tight tolerances. You can get tight tolerances up to 0.005 with lost wax casting. Production costs. It requires less time, less resources, and less manpower to cast your parts, which leads to overall lower production cost. Waste elimination. Because lost castings waste little to no material, and all the waste material can be reused, makes it highly efficient. Complexity of designs. Parts produced through lost wax casting are lightweight and full of small details and features. You can get fine details in your parts, which offers you design flexibility, with the option to choose nearly every material for your parts. Applications of lost wax casting. Lost wax casting's applications range from aerospace to the food industry, providing benefits for various sectors. Its precision benefits many industries. Aerospace, to produce outlet manifolds, seal, flaps, bearing housing, vertical support, airline engine, jet engine airfoils, bearing support, and nozzle guide. Automotive, to produce engine components, fuel systems, compressor parts, aluminum space frames and suspension systems, and gearbox components. Oil and gas, to produce gate valves, slip linkages, tube handling devices, valve brackets, elevator parts, and locking levers with aluminum, stainless steel, and alloy steel as primary materials. Chemical, to produce bullhead tees, static cast fillings, catless tubes, heater hardware, elbows, and ethylene coils. Food, to produce meat slicers, racks and grills, various poultry processing tools, and parts for ice machines. Medical, to produce medical implants, surgical tools, and other medical instruments. Comparative analysis with other casting methods. Another casting process like die casting excels in design complexity, surface finishing, and material compatibility. However, die casting may be limited in achievable design intricacy, whereas lost wax casting allows intricate detailing with minimal post-processing for smooth surface finishing. Conclusion. Its ability to precisely accommodate various materials like aluminum makes it one of the leading casting processes. Sunrise Metal features aluminum die casting for its customers to provide them with superior results for their metal working projects. Contact us if you have needs on die casting.